So good afternoon, everyone. Thank you so much for joining us. And welcome to the 6th show and tell for round 2 alpha projects of the Strategic Innovation Fund. So this one, as you can see, is about cross-vector approaches for decarbonisation of transport. Cross-sector approaches for decarbonising transport are crucial for achieving deep and sustained reductions in greenhouse gas emissions. This is particularly given that transport accounts for between 16 to 25% of all global emissions. Whilst the advantages of cross-vector energy integration aren't exclusive to transport, some of the things that the transport sector will inevitably benefit from include greater innovation, integration, and collaboration across different sectors, which leads to more effective and comprehensive solutions that enable a low-carbon transport system. Sorry, 1 minute. I think I had a couple more notes that I wanted to share, but I cannot see them. Okay, so next slide, please, Amy. Thank you. So I'm Serena Siroso. I'm an innovation lead that sits in the Ofgem, well, in the UKRI side of the Ofgem SIF team. I primarily have a background in hydrogen, but I'm now looking more at the intersection between the gas and electricity network. So very grateful to be here. Next slide, please. So this is just a bit more of an overview about SIF. I'm sure many of you are familiar with it already, which is why you're here, but just in case you're not, as you can see, SIF has a two-pronged approach. We constantly have the vision that informs the direction that we're moving in, and then the purpose underneath talks more about why it is that we're doing what we're doing. So there's lots of kind of cross-pollination, which is why, as you can tell from the big number of show and tell sessions that we've been doing, it generates lots of different innovative solutions that can support not just the networks, but also wider society as a result, and contribute to planet benefits. Sorry, I've had a busy morning. Can contribute to planet benefits whilst at the same time generating economic opportunities for all involved. Next slide, please. So the Strategic Innovation Fund, as you can see, it's paid for by consumers, but via their energy bills. Part of the money that goes to Ofgem then is circled back into the networks via the Strategic Innovation Fund. You may have been familiar with the Network Innovation Fund, the Network Innovation Competition, or NIC. SIF has been introduced to replace NIC to better facilitate and accelerate the move from network innovation becoming business as usual. So we have just under £500,000 available over the next 5 years. And the purpose of SIF is to support network innovation, to ensure that networks are ready for a net zero future where the energy system will look and act very differently. But it's also in place to support consumers, all the different types of consumers, including those who are more vulnerable or sit in different demographics and perhaps run the risk of being left behind. So I won't go into the numbers, but you can see there already there is huge potential for SIF to be incredibly impactful across a number of different areas. Next slide, please, Amy. Thank you. So I'll just go over the agenda very briefly. Next slide, please. Thank you. So we've got 2 projects that we'll be covering this afternoon. Both of the projects will have about 25 minutes to present what's been happening, as well as for any questions, as well as to answer any questions that you may have. As you can see from the bottom of your screen, there is a Q&A function. So as the presenters are talking, please feel free to drop your questions in the chat in order that we can make the most out of the question and answer bit at the end. I think that's it from me. So I'll hand over to the Park and Flex team. Thank you, Amy.
Thanks, Serena. So I'm here from UK Power Networks to represent the Park and Flex team. What the project is hoping to achieve is understanding what flexibility is available from public car parks. So the project team consisted of UKPN, Baringa. We've got Dan presenting today, who are a specialist energy consultancy with commercial and market expertise. We have Fermata Energy, who are a technology provider who specialize in bidirectional EV charging and flexibility. And then we had UK Power Network Services, who are our unregulated part of our business. And they were a project partner because they managed the electricity network at Stansted Airport, who were a stakeholder that were key for our project. If we could move to the next slide, thanks. So just to establish what the problem is that Park and Flex was trying to solve or is trying to solve, we know that there's going to be a significant new power capacity required to support the rollout of EV charging infrastructure. That's forecast to be 9 gigawatts by 2035. And we also know that there's also going to be additional load from heat decarbonisation as well. So looking at ways to explore flexibility is going to support us. So delivering net zero will require the integration of new low carbon generation as well as demand onto our system. And as I just mentioned, flexibility resources such as vehicle to grid can help support us with this. Within UK Power Networks license area, our distribution future energy scenarios are forecasting around 3 million EVs in 2028. So this higher peak demand will require costly infrastructure build out if we're looking at traditional means, but having an increase in flexibility is an alternative that can offset some of these reinforcement costs. System operators such as ourselves need additional sources of flexibility to address some of these constraints and help bring down the cost of flexibility. EV smart charging is pretty commonplace today. So now that's why this project is looking to see if we can find new sources of flexibility. And then on the consumer side, there's concerns around EV upfront costs versus traditional internal combustion engine vehicles. So by looking at new propositions that can deliver value for consumers, it might make the switch to an EV more attractive. If we move to the next slide, thanks. Over you two, Dan.
Thanks, Jack. Hi, everyone. I'm Dan Bolton from Baringa. I'll be taking you through the next few slides, which give an overview of Park and Flex and what we're hoping to do with the trial in the next phase and how we came to the conclusions there. So part of the solution for what Jack was talking about in terms of the massive future need for new peak grid capacity could be parked cars doing bidirectional charging in public car parks. So there's a massive potential here that we've modeled as part of UKPN's network. There could be 4.3 gigawatts of V2G or V2X capacity by 2050. This is in a sense kind of massive grid scale level batteries that are kind of sitting there. So there's a lot of latent flexibility. Electric vehicles plugged into bidirectional chargers while they're parked and not being used to drive around could operate effectively like behind the meter batteries to offset peak load and therefore deliver a significant cost saving for consumers by avoiding expensive network reinforcements. They kind of have a V2X here has a double benefit versus smart charging, even because a smart charger may not charge during peak periods, but a bidirectional vehicle to grid charger will not only not charge during those peak periods, but it can also generate to supply other loads or to generate power into the grid. So you're kind of getting a double benefit from these in terms of reducing peak load and smoothing the shape and increasing network utilization, which will have a significant cost-saving benefit for consumers en masse. There are also societal benefits, as Jack alluded two in terms of financially reducing total cost of ownership of EVs. So in the future, if it becomes more commonplace for EV drivers to be plugged into bidirectional chargers when they're parked up, providing grid services or providing network peak load offset, they can receive a financial benefit for that, and we'll kind of go into that in a bit more detail in the future slides. And there's also a carbon emissions benefit here, because these vehicle to grid assets, these batteries will operate effectively like large-scale battery storage assets once they're aggregated, and they'll be charging at periods of low price and low carbon, and discharging at times of high carbon. So in effect, there's like a carbon spread there, which we've also calculated as part of the beta application, the CO2 and the financial version of that saving at the UKPN and the GB level as well. Next slide, please, Amy. Yeah, so just a quick overview of the work we've been busying ourselves with over the alpha phase. So we've been doing stakeholder engagement with a lot of different potential partners in terms of car park owners and host sites. So we're progressing well with a couple of airports at the moment who are keen to participate within the trial. We've also spoken to a few other potential site operators to kind of gauge their appetite for this innovation trial. Well, package C, we've been doing some modeling and analysis, looking at what value we actually expect these V2X chargers can generate within the market, and this kind of is varying by car park archetype. So there's obviously different types of car parks in the market based on location, and then what kind of drives that is also drives dwell time, which is another key determinant of the value that you can make on a kind of pounds per driver per stay basis as well. So the longer the car's parked in place, the more flexibility markets it can access, and and therefore kind of the overall business model and customer proposition is more favorable in those kind of long stay settings, which is a main driver of the reason why we've decided to do it in an airport where people are typically staying for 5 to 10 days on average. We were also developing customer propositions. So how would you remunerate drivers for this? What's the value? How do drivers want to best capture that value? Is it just a parking discount, or is it another type of proposition there? And this is a key thing that we want to test within beta. We were also working with Fermata, who Jack mentioned is the technology partner here. So their kind of expertise is in the remote control optimization and dispatch of EVs plugged into bidirectional chargers. This is already a proven technology, so it's just about helping Fermata to integrate with the charger manufacturer that we have contracts with, or we will contract with, and with the site energy supplier as well, because there is a sophisticated IT integration that needs to happen between all parties to get the optimization up and running. We're also then designing a bit about the beta trial, which we'll go through in a bit, and I'm working with UKPN services to do some scoping of the civil and electrical works that will be required to install chargers at the host sites. Next slide, please. So a bit of a breakdown of the expected value that we have modeled in a long stay car park. And by long stay here, as I mentioned, it's when a customer will be parked at the site for more than 24 hours, which allows us to do at least one full cycle of the electric vehicle battery, which allows it to do one kind of price arbitrage where the car battery would charge up overnight or during the middle of the day when prices and carbon intensity is lower, and then it will discharge to supply the site when prices are highest, capturing a price and carbon spread there. So that's what wholesale arbitrage is in our waterfall chart here. That makes up the greatest amount of value that we think we can capture at the moment. Duos optimization is the next one, so that could be higher or lower depending on the site and depending on where they are in the country, the DNO region, and depending on their voltage connection as well. But that could obviously be higher than what we've got here. We've just got it here because the site in question is actually an extra high voltage site, so they don't not pay a lot of duos on that site. There is an assumed value for balancing mechanism here. So there was a recent grid modification around virtual lead party that's aimed at increasing participation of distributed assets into the BM. We think that this may be hard to access for the trial because of the immaturity of that and the introduction of that being only so recently. However, we are working with the electricity supplier on the site to develop the potential for us to at least proxy that value in a certain way if they're unable to access that at the beginning of the trial. But they are developing their own software to be able to allow us and others to do that at the moment. And then there's a big amount of value there for DSO sustained service, and this is a service where if you're in a constrained part of the network, DSOs will kind of offer you a flexibility payment for helping to manage that location specific constraint. So this is where V2X and behind the meter batteries, for example, and load flexibility in general is most valuable, where there is already a specific network constraint. You can see that's already adding 100% of the value, and without that it would kind of impact the kind of charger business case quite heavily. But we do expect in the future that there'll be a lot more constrained zones, and then this amount of value will be more accessible to everyone in different locations. But at the moment, assuming that the chargers used all the time, 100% utilization, we think you can make around £4,000 of value on average, which will result in an IRR of 10% based on a charger capex of £12,000, and that's a 22 kilowatt charger, by the way. Next slide, please, Amy. So I mentioned earlier about why we're picking to do the trial within the long stay car park settings now. So we think that because the value is highest in these settings, it's a good opportunity for us to take learnings for the other settings, because if EV drivers don't want to opt in where value is currently highest, we think that is a good barometer and indication for whether they would opt in other settings where value is lower. Rationally and logically, we think that makes sense. We do recognize, however, that long stay car parks are not the most prevalent of car park spaces. The majority is in short and mid stay. So people going to the supermarket, for example, that is where most car parks are. That is where potentially the more scalable and more capacity is in flexibility in car parks. However, because the value is low, the cost of the charges is currently relatively high. We are seeing much more value in the customer proposition in long stay at the moment, but we think this learning will enable the development of more propositions in those settings within the future. And we have kind of a long time left to get to net zero, and a lot of technology development and cost reduction could occur within that time that unlocks those other settings. Next slide, please. So yeah, just kind of a cartoony version of the customer journey that we've designed for this airport. So a customer is going to book online at the airport for their car parking before they take their flight. On the online booking system, if once the system recognizes that they've got an eligible vehicle based on their license plate, there will be a pop-up or equivalent asking them if they would like to participate in this trial. Then they'll have linked to the T's and C's, and they'll be offered a discount, a fixed discount based on their length of stay, and TBC, but we'll be working with the airport to design the exact incentives, which could be a free or partially free battery charge on return. They could have a voucher to spend in the airport. They could just they could just have a simple parking discount at the point of purchase, which probably is the simplest way. But there's other options to give them carbon offsettings or airport benefits such as queue jump and things like that. But we're kind of trying to test whether the amount of value is high enough for drivers to allow a third party to have control of their probably new and expensive electric vehicle while they're away, which has never been done before, and is a really interesting kind of question to consider about how people view ownership of their own assets and about the mindset of that as well. So yeah. Next slide, please, Amy. This is a kind of high level schematic of the energy and data flows that kind of need to happen. We won't go into too many details, although from the left to right here in the diagram, there'll be the electric vehicle plugged into the bidirectional charge point. That will be sending data flows about the availability and capacity of the battery, such as the state of charge and the when it's plugged in or not, for example. They will be sent to Fermata's system, who will kind of aggregate all of the capacities up of all the batteries in its portfolio. They'll be receiving live pricing data from the energy supplier. They can then run an optimization on their platform, which basically says charge when price is low, discharge when price is high, and then they will send those volumes that it nominates back to the energy supplier, who will put that in his traded position to lock that in to actually capture the value of the trade. And then Fermata will send the dispatch profile back to the charger, who will then instruct the car to charge and discharge. That's a very simplified version of the optimization that will be happening, but yeah, it gives a flavor of roughly the activities that will be happening on Fermata's side. Next slide, please, Amy. And this is the final slide here. So we're just kind of, as mentioned, really, we're trying to assess the actual value of V to X here in this in this car park setting. So is the value higher or greater than we've modeled? That's one of the key questions. Will customers actually opt into this? If yes, or if no, why not? We really want to try and understand and unpick that. And we're also kind of looking at whether the value that it does generate can support a viable business model within the future, given all of the kind of the supply chain ecosystem that needs to be involved. So is there enough value created by the chargers and the batteries to remunerate everyone who's involved fairly, whilst also giving the drivers enough value to participate in the scheme? Okay. Is there a Q&A part now, Amy? Yeah, thanks.
Fantastic. Thank you so much, Park and... Oh, I'm so sorry. I can't remember the name of the project.
Park and Flex.
Thank you. Okay, that's what I thought. Thank you, Park and Flex team. That was really interesting. I can see one question. Oh, two questions now are in the chat. Just a reminder that if you do have any questions, please feel free to write them in so we can answer them now. So the first one is from Jim Wrigley. Does the £2.4 for the customer per day come out of the 4.5k annual revenue, or is this on top of it?
This was coming out of that. Yeah.
Okay, great, thank you. The next one from Anonymous is, how does the value per day from V2X compare with parking fees in long stay car parks? Heathrow's website quotes £30 to £40 per day per car. Does this mean it's more for fleet owners than individual owners?
So staying for 10 days in an airport, I think from memory it would cost you 120 to 150 pounds or around that. So you would be getting roughly 20 pounds discount for that stay. So it's kind of 20-ish less 20% this discount you would get, I think.
Great, thank you, Daniel. Jim's posted a follow-up question to the earlier one regarding the 4.5k annual revenue to the customer. What are the costs of managing the trade? And then examples include managing the platform and the aggregation and so on of energy contained within the 4.5k annual revenue.
Yep. So so there's a range. There will obviously be aggregator fees. So aggregator being the solutions provider who does the optimization and kind of the optimization and the controls. There will also be the energy supplier that's involved in just kind of the normal energy supply for the site and any fees that they charge for trading the flexible volumes. There'll also be a proportion that goes to the customer, which we've assumed is 25% for now, and then there'll need to be a payment also back to the asset, to the owner of the chargers, which in this case is going to be the airport, who also owns the car parks. So car park owner, the aggregator, the supplier, and the customer, and potentially the charger operation and maintenance contract will all need a share of the value. That means that the value has to be split four maybe 5 ways. So this is kind of a key part of what we want to test within the trial. Is there enough value to keep everyone happy? Within the innovation kind of sandpit environment that we're going to be designing, but then also in the long term, is there enough to sustain a viable business case here? So, going back to the specific question around the supplier, in this case, the supplier is going to be doing it free of charge. They'll be just kind of sending back price signals, but back and forth with some API integration that they're happy to do for free as part of the trial. And aggregator fees can vary in terms of amount and also in the format of those charges there. So we see some people doing a revenue share between 10 and 20% of the gross value, but we kind of see that in the long term moving to a platform based fee, which is more on a kind of pounds per kilowatt value, which would be more kind of down in the 5 to 10% of value level. But these are commercial points that are all up for negotiation within the contracts, and they're dependent on kind of the value that we all assume is going to be within the project.
And we've only got time for a couple more, but I think this leads us nicely into one of the questions that's been asked, which is there a risk of the values for V2X getting depressed and potentially bottoming out as more megawatts come onto the market? And if so, does that mean that you're only quoting figures for first movers for a few years?
That's a good question. most value in the energy market is subject to cannibalization. You see that in large scale renewables as well as in the small scale flex market. There is a finite demand for flexibility. We see this in, but the battery storage market is a comparable one. So obviously, well, they're the same kind of flexibility markets that we see. The world that we'll be trying to access in terms of for bidirectional chargers and for flexible demand. The more flexible capacity there is, all else being equal, the less value there'll be to go around. However, there'll be an increasing demand for flexibility as well on the system in terms of demand nearly doubling by 2050, as Jack mentioned at the beginning. Massive amounts of new renewables. I think the government's still targeting 50 gigawatts of offshore wind. That's going to bring a great amount of intermittency, where we need more flexibility to actually service that. So we see that flexibility markets can become saturated, but then there have been new markets that are regularly introduced by National Grid that kind of they increase the value back. We've seen a big peak and troughing in the battery storage value over the past few years, and DSO services are something that are still very nascent, but we project the value of those to be really high, where kind of localized grid constraints are flexibility being heavily incentivized in those areas, and Baringa does a kind of a projection of those market values, which we think will be increasing. So yes, the answer to that is our projection is our best view of what we've got today, based on increases of demand and supply for these services. However, they are subject to just to kind of supply and demand market dynamics as well.
Great, thanks, Daniel. Last two questions very quickly. So there have been a few in here about concerns from the vehicle owner's perspective and with regards to manufacturer's warranty and potential insurance premiums. And so is that something that's been considered? And additionally, does the project offer any mitigation regarding potential overcharge damage?
Yes, so we have written approval from Nissan that this does not breach the warranty of the vehicles. I think Nissan Leafs at the moment are one of or the only make of car that is bidirectional at the moment. But there are a lot more that are about to be released into the market. They're obviously they're bidirectional enabled for a reason. That's kind of part of what the proposition is will be in the future. So yeah, so Nissan have said this does not breach the warranty. They're happy for the cars to be used in this way. Following from that, we don't think it breaches insurance, although we are obviously looking into insurance and kind of liability cover for specifically operating them at the host site, because they would have their own requirements about operating certain assets at their sites. But in terms of car insurance, we don't. This will not impact drivers' insurance.
Great, thank you. And we'll just wrap up with one last very quick question. It's great to see all the engagement. Why doesn't the airport develop the business model and commercial arrangement to leverage flex from their car parks? How do they differ from other flex site developers who have to work out their own commercial viability when seeking a grid connection?
Could you repeat the first part of that question, sorry?
Why doesn't the airport develop the business model and commercial arrangement to leverage flex from their car parks?
You mean?
Dan, is it okay if I take that one?
Yep.
Yeah, just real quick. I guess thinking a bit about that is the difference probably in the stakeholders involved. So essentially, it's not really a matter of the airport's business model, but it's that there's a benefit to the networks of leveraging an asset that's owned by consumers, because it's the end consumer that owns their vehicle. And this whole trial is kind of testing how, well, what can incentivize end consumers to make their own personal private assets available for these kinds of network services. So it's a little bit different than an asset like battery storage, for example, that was designed for commercial reasons and built specifically to participate in Flex. So that's kind of my idea on that.
Can I also jump in on that? And I guess for everyone on the call, that wasn't a second Dan talking, so that was Claire from Fermata, one of our project partners. So the reason, I guess, to address the first part of the question, this project is a proof of concept to understand how much flexibility can be offered from public car parks. And from one of the slides that Dan was presenting on, we identified that the most value comes from long stay car parks. So to demonstrate, I guess, the most value, that's why we're working with an airport, because they're good candidates to have long stay car parks, and for us to be able to test consumer propositions and whether they want to engage with V2G. So if this concept if this concept's successful, it can obviously be scaled to other businesses who have public car parks. So it's not specifically focused on airports.
Okay, that's great. Thank you, Jack and Claire. We're now going to move on to the next project, Lightspeed. So over to the Lightspeed team.
Okay, I'll take the lead again, Amy. Thanks for that. Yeah, if we stay on this slide. So Lightspeed is another electric vehicle charging type project, but it's coming at it from a different angle. The project partners were ourselves, UK Power Networks, who are a DNO. We had SP Energy Networks also as a project partner, and another DNO looking at it from a scalability perspective. Then we had Ataskis, who are going to help present today. They're developing an EV, or they have developed a V2G charger for us, and as well the software. And then we have Brighton and Hove City Council. So they're the local authority partner for our project. And these are the sites within their area that we were looking at. And then we had EV Energy, who were completing stakeholder engagement with customers, but they have their own smart charging platform. So if we move to the next slide, thanks. So in the previous presentation, we heard that I guess EV charging is going to add quite a bit additional load to the network, and this project is coming at it from a different angle, that not everyone has a driveway. So approximately 30% of households don't have access to off-street parking. So to help facilitate the transition to EVs, we need to find alternative ways where people can charge their vehicles. What we have found, not only just in this project, but from other previous projects, there's a number of barriers to, I guess, the wide scale rollout of public charging. One of them being the deployment across not just our network, all DNO's networks is constrained. So that takes time, and it's costly to provide the capacity there. Previous engagement with local authorities is they don't want a lot of street furniture, or in this case, EV chargers along the footpaths. So we were looking for alternative ways or innovative ways to provide chargers. The current lamppost charging that you might have seen in the streets today is unidirectional and slow charging. And for people actually charging using public chargers, the cost is usually higher than if you were to be charging at home using a charger on your own driveway. So what we were hoping to achieve in the alpha phase of Lightspeed was, probably should be written in past tense, but Ataskis were able to develop a prototype, both the hardware and the software for a charger. We're working with Brighton Council. We were able to shortlist a bunch of sites, go out and visit them, and then working with our connections team, identify which ones had existing capacity so that we could select them for the beta phase. And then EV.Energy completed some customer engagement with their customers, and then Ataskis were looking at the route to market, and Spen were looking or helping support us in terms of, is this solution scalable to their license area, as well as helping support engage with some local authorities in their area. So if we move on to the next slide, and Phil will take over.
Thank you, Jack, and thank you, everyone. I think Daniel pretty much says everything from a technical point of view in terms of what the importance of V2G is to the market. And I agree with the comments around the benefits, the large benefits that you could get from long stay car parks. But the beauty of what the Lightspeed project is looking at is when you think about the same scenarios from a medium to short stay, the ability for it to basically gather the numbers, because you have more throughputs, more activities, more vehicles, plus also the ability for people that don't have off-street parking, for them to be able to safely transition, you know, to actually acquiring electric vehicles. As everyone knows in the space, one of the biggest challenges is the access to actual charging infrastructure, and it's charging infrastructure that's effective, that's easy to use, that's close to home, and obviously a significant focus as to how the grid can be impacted by the rapid scaling of those charging infrastructures, as well as an understanding of the behavioral profile. One of the key themes that we looked at in the project was to understand what type of charging infrastructures the users would like, how they would want to see it. As Jack has initially said, less on-street infrastructure, less infrastructure, you know, and being able to also leverage those short and medium stay car parks, such as the shopping malls or leisure centers or anything within those spaces where people basically have to interact, as well as leveraging the opportunity for us to be able to create this added benefit of V2G. I guess I'll talk about the hardware first, and then we'll go into the interesting bits around what we learned. So if you go to the next slide, please. So what we found out very quickly was the fact that a lot of people don't know what V2G is, you know, and that's because in itself it's quite novel as to what you could use the electric vehicle to achieve beyond charging it and utilizing it for transport. So that pretty much informed the development of our prototype, where we focused on the how we can put technologies that are unidirectional as well as bidirectional for customers to be able to transition in terms of the knowledge, in terms of the utility of the product, and the capacity, or at least the added value that V2G brings. So as part of the development of the DC bidirectional charger, we also installed a 7 kilowatt AC unidirectional system. So if a customer basically doesn't want to do bidirectional, or their vehicle is not able to basically do bidirectional, because as Daniel said earlier, not all vehicles are capable of participating now, but as the trend goes into the next 3, 4, 5 years, we expect more of these vehicles to bidirectional. They shouldn't be disenfranchised. So we also built our capability into the system. Also, there was a very strong focus on how and where this can be placed within the actual grid network, so that you can actually serve flex services and export services based on the requirements and geography and all the other challenges that we currently have in delivering city scale flexibility. Next slide, please. There was a strong focus on three of the four parts of the software development, where we were thinking of the interactiveness, the HMI, you know, the charger management, in terms of what is the best way for us to be able to deliver a wider city scale across Brighton, bidirectional flex charging activity, you know, and understanding the fact that certain areas might be grid constrained and other areas might not, and understanding how we can start to drive the whole trajectory from standard V1G of standard charging approaches to incorporating some smart charging activities, you know, that can actually generate revenue for these customers, and hopefully, you know, as the trend goes, start to offer them the capacity for this novel approach of being able to use the car as source for energy export. So a lot of the focus was around how you build the energy management tool, how we can optimize the system, look at the behavioral profiles as to existing charging behaviors within the grid or within standard utilizations of public charging infrastructure, and how that trend can also start to be used to incorporate the knowledge of V2G. And the whole thought was on the premise of understanding the price of energy, understanding when it is cheapest to get energy, which typically in today's market is when there's significant decrease in demand, and usually at night, and seeing how we can use those vehicle infrastructures as arbitrage or storage sites, and then the energy can be collected back when it's needed. But also being strategic, because we're looking at a city scale where it is best for those vehicles to be located, for them to be able to participate either in the discharge of energy or providing some additional flex support, as the different feeder pillars and different connection points across a city would obviously have different capacity requirements or capacity constraints depending on where you find yourself. But another interesting part around this was also understanding the ability for us to model charging prices. So the bidirectional charger which we built focused on being able to operate as a fast charger in 22 kilowatts, but also had the capability within it for us to be able to slow down the charge rate down to 3.5 to 7 kilowatts, and also increase it or ramp it up based on what the expected future price would be. So a typical example would be, we already have the price forecast that energy prices are going down in the next 1 hour. So we want to encourage our drivers or incentivize our drivers to basically ramp up their charge and find a location within the city where this is being operated, but also understand that the price might slightly go up in the hour after that, and start to see how we can slow down the rate of charge down to say 11 kilowatt or 7 kilowatt, because we expect that by hour 3 the price would even go down further. So there was that element of dynamism. But in the reverse as well, we also understood the need for us to be able to discharge, and for our knowledge, we set the discharge capability down to a maximum of 11 kilowatts, where you don't want to rapid discharge the vehicle, even if we know that there is very little to no impact, as Daniel has said earlier, on the quality of the battery or the performance of the battery or the aging of the battery when you're doing slow discharge of vehicles. So typically the larger population will probably benefit from a 3.5 G99 level discharge of vehicle, but also that capability for us to ramp up the discharge can also be implemented if required. And the reason why that approach was taken in the development of the software, or the methodologies behind the software, was because we understand that capacity requirements needs to be factored when you're actually discharging, and also the ability for us to basically price match what the grid is requiring from us, as well as the potentials of being able to elongate the sustainability of that market, because you don't want to provide too much energy back to the grid. If not, you're pricing yourself out of the market, but also provide the required amounts that basically provides the best value and benefit to the customer. So that was a lot of the focus that we looked at from a software point of view. There was also element in terms of the interactiveness of this, looking at accessibility issues, because when these infrastructures become live on streets, you don't want it to be discriminatory against people living with disabilities or any other form of challenges, and making sure that the design, and this was with a lot of help from the local authority, actually has those elements that allow people that are smart enough, educated enough to use an app, but also if you don't have an app, the same system, you're able to use it on the HMI screen or the interactive screen on the charger itself. What was also very critical for us was, based on the advisement and the engagement of various stakeholders within the local authority, that we had to build a suite of solutions where, if there was a lamppost based solution where this charger can be installed, and we can ramp up the slow charging capability of up to 5 to 7 kilowatts to faster charging solution, faster charge, the ability for us to use the bidirectional converter embedded into that system was built. But also, if you found yourself in a leisure mall where you could do public charging, we also built systems for that, and that hopefully is what we want to test and trial in the beta projects, so that we can actually understand how future rollout, obviously learn more as to what is the best approach with which this technology can be can be scaled across multiple local authorities. Next slide, please. Another critical element was around the intelligence of how this is operated. So the best way to describe this slide is to put a scenario in play where there is potential flex capacity in postcode X, but you're currently in postcode Y, you know. So what we're looking at from a smart charging intelligence for the potentials of either benefiting from flex or bidirectional discharge is to see how well we could leverage the geography of a local authority to encourage drivers to go to physical geographies where they could benefit from both activities, but also not disenfranchise other drivers that don't want to make that journey. Well, what we're beginning to see is two layers of financial opportunity where you can do export, which is typically what you will get from V2G. But for drivers that are willing to basically make that additional income of basically moving from point A to point B in a short or medium stay scenario, we can incorporate that level of intelligence within the system for them to be able to benefit from this short and medium stay opportunity within the charging infrastructure, and also leveraging the fact that the system is going to be so dynamic, it needed to have its own AI model embedded into it for those type of decision making that allows us to basically provide control, provide integration in terms of collected data from the grid, making sure that the system is better served rather than a basic charging discharging tool, which the current competitors in the market are looking to offer. Next slide, please. This was in terms of how the aggregated data could be faced, because there are different stakeholders that we would have to work with, one of which is the local authority who will be providing the interface for the landlord system. So there's elements of CPO and sub CPO capabilities within the software that allows us to be able to aggregate the various activities that are happening within the wider city scale or council scale, so that they can better understand and visualize things. But also this also serves as a tool that will be used to obviously encourage customers to go to areas where they are best served by this. But on the reverse side, this is also providing significant benefits to the plan is to develop the system to be able to provide significant benefit for DNO and DSO services in terms of understanding where those constraints are and how the user can basically provide a service or some form of flex or bidirectional service within an aggregated system. Next slide, please. A lot of those learnings are from the physical development of the hardware, an understanding of the accessibility requirement, an understanding of the people element of the project, as well as an understanding of how the layers of dynamism within the software has led us into preparing our mindset for what a beta would look like. And it's going to be focused on location and the dynamism within location in terms of delivering both slow charging, fast charging, and the potentials of also rapid charging in the unidirectional or the V1G direction, but also leveraging the same assets, which has the capability, that level of dynamism to basically provide services for smart charge and energy export, in the V2G direction. And so far, we've identified 45 sites. Working closely with SPEN as Scottish Power as a DNO, we're also looking at the project to also have a beta activity within one of the local authorities that they're working out of. And we've done an initial DEX review and worked with the DNO to identify the potentials of how the deployment would work, looking at different layers of areas where there are significant constraints, mild constraints, or areas where there are no constraints, so we can start to measure the changes and how that impacts the type of investment the DNO will be required to make. Right, but obviously identifying areas where little or no investments are basically made within the within the distributed area, and then start to model what those investments are required from the DNO, from the grid side, what the activities in terms of understanding the customer behavior and shifting customer behaviors in terms of transitioning from V1G to smart charging to V2G. But also there's also a significant element around pricing, which I think Daniel also mentioned in this conversation, and looking at new approaches to which this can be priced better, because ultimately what these electric vehicles are batteries on wheels. And if you are a prosumer with an electric car, you definitely should start to look at opportunities as to how you can maximize your benefits, either if one of the aggregators or one of the stakeholders within the value chain is providing enough space for you to be able to benefit from. And that's a very critical element that we are considering to look at within the beta as well. And obviously understanding what a large scale rollout or large city scale rollout would look like, understanding the complexities around the business models, and understanding how we can start to learn how the users, start to transition from their existing knowledge, which the next slide nicely discusses. Please, if you go to the next slide. Understanding how the users basically would interact with this. During the alpha, our colleagues from EV Energy did some amazing work in terms of understanding the user preferences, the incentive models, the behavioral profile, and the knowledge. And this particular piece of knowledge came back where the reason why anybody would want to participate in this is because they want to make money. It's point blank straightforward. The monthly cost of an electric car averages between 350 to 600 pounds. And if you're going to help me cut out 20, 30, 40 pounds of that bill every month, then I'm interested, and that was very high on the list in the work that was done. But also understanding how best these services can be delivered in terms of the transition of knowledge from what smart charging and the different flex activities that's currently being benefited right now, and also the addition of V2G, what that potentially offers within the market. And also there was also a very critical part as to what exactly do they want? Do they want to get their returns on a daily basis per activity, or do they want to get their returns on a monthly basis in terms of annual basis? And obviously there's a significant focus on monthly, and obviously rather than using it to offset bills, some people want to get cash. And the fact that we're looking at medium to long stay as well, understanding how that can be aggregated across the verticals and across the horizontals of the various things that need to come together is definitely something that we want to look at within the beta and build that transition from what is currently known to the potential futures. Also, it's also very critical to mention the fact that OEMs are actually looking more into the release of more V2G vehicles. So it's around understanding how that can also drive the impact on the grid with regards those capacity requirements that needs to be adjusted or shifted, what the total cumulative annual GB energy consumption profile looks like, and what this prosumer EV vehicles, can offer in the offset of those potential peaks that are going to come up in the future, or basically acting as escrow holding site for electricity for when they are needed. I think that's about the last slide. Oh yes, sorry. Obviously, our friends from EV Energy also made some featural apps, that actually helped in understanding the interfacing and the interactions between the consumer and the product and services that will be built. I think the next slide is questions, or the slide after that. Sorry, the next slides, please. Yes, in terms of what we want to do next, we plan to obviously deploy 200 chargers, quite a large project, in the Brighton and Liverpool council areas. And we're also looking at different approaches for energy supply mechanism, either to the CPO or either through the supplier. And a lot of the things we wanted to look at here is to understand how this would work within a supplier arrangement, and how this would also work when operators are basically working across multiple suppliers, and obviously discussing the potentials for a different subvention where license categories can be built, or at least can be trialed and modeled to basically give more prosumer rights or generation rights, which is EVs actually creates towards to the consumer and the prerequisite benefits from that. We also want to look at flex use cases, which is inherent because this has not been looked at from a large city scale rollout from off-peak or from public infrastructure, and what that dynamism would look like as to how it would fit to someone who only needs charge for an hour as compared to someone who needs charge for the next 15 hours. You know, understanding the variabilities within that and how that would also impact the grid. There's a strong significant focus from what we are developing right now that there would be need for us to start to look at potential impacts that existing policies would actually play within the V2G space, and obviously enhance the need for more revenue generation, as I think there was a previous question earlier in terms of the excess of this within the market or the increase in this vehicle within the market. Wouldn't that just create a pricing out? It's actually looking at how that can be sustained for the longest possible time, and obviously how electric vehicles themselves, batteries on wheels, can start to incorporate itself into that 0.5 to 1% battery bank, you know, that the UK currently boasts of, and see how that can actually act as an increase, or at least increase or decrease in the battery storage requirements in the country. And obviously looking at how this can also be scaled on a beyond the 2 city councils that we are looking at. I think that's my presentation, and if there are any questions, I'll be happy to answer them.
Great, thank you so much, Jack and Philip. But unfortunately, we are at time. Having said that, the only question in the chat is one from the previous project, and I think that I answered it in part anyway. If anyone does have any more questions, though, I am assuming that we will be able to pass them on to the project team and share the responses with you after the webinar. But thank you so much all for joining us this afternoon. Thank you, Park and Flex and Lightspeed teams, for your really insightful and interesting presentations. Thank you, Amy, for sharing this slide. As you can see, we've got a few, just one more actually, two more show and tells, one in the morning on supporting a just energy transition, and another in the afternoon looking at transitioning local energy systems. Chloe's just helpfully posted the link in the chat where you can register for the final sessions. And yeah, if you have any more information, please do. If you'd like any more information, please do get in touch with us. As you can see, we have loads of different channels for engagement and interaction. So yeah, thank you so much for your time, and we look forward to speaking with you again soon.